Okay, students, now we are going to study one of the most important, most difficult, most typical isomerism. Okay, isomerism is very easy topic, but in isomerism, the most difficult topic and most scoring topic, high scoring topic, if you understand it properly, then it is a high scoring topic. That topic is nothing, none other than tautomerism. Okay, so what are the special things in this one and how it is questions are going to be, how to deal with them. We will start right from the basic at which chem. Okay, so tautomerism. Tautomerism is a special case of the functional isomerism. Actually, it is not nothing new isomerism. It is a part of the functional isomerism. How functional isomerism, that we will discuss when you go through the examples. When I give you examples, that will be functional isomerism, why it is called functional isomerism, what is the special condition that should exist. Okay, so it is a special case of the functional isomerism only, it is not separate. Only the other condition that it should follow is both functional isomers should exist in dynamic. What is this? Dynamic equilibrium. Okay. Normally two functional group. Let us take ketone and aldehyde, or alcohol and ether. Okay. So let us take CH3. Simple example I am taking so that you should understand it in a simple way. Okay. So CH3O CH3. So these are the functional isomerism. So functional isomers, either the molecule will exist in this form or will exist in this form permanently. When it is in ether, lifelong it is going to be ether. If it is alcohol, lifelong it is going to be alcohol. But if there is any transformation from here to here, then such functional isomerism is called as a tautomerism. Difference between tautomerism and functional isomerism understood. When two functional isomer exist in dynamic equilibrium, then such functional isomers are also called as tautomerism. Tautomerism is a special case of the functional isomerism. What is the special case? Is it understood? And how they are going to be dynamic equilibrium? If they both exist, which is quantity will be more? How we have to identify what are the factors affecting their stability? We are going to study. So, but for that you have to maintain your interest till the last. Watch the video till last and try to maintain the notes. Okay, so without notes there is no use of it. Organic is, all of you should keep on writing, keep on noting the some words. Like this bookish language you will find out in all of the books or notes, but after listening to my explanation and writing them with your own words is most important. Okay, next, both isomers. Suppose this is not isomer, the both isomers which are existing in functional isomerism and dynamic equilibrium, then they are called as tautomers. They are called as such functional isomers which exist in dynamic equilibrium with each other are called as a tautomer. Such process is called as a tautomerism. Tautomerism is a process. Tautomers are molecules. Okay, compounds. Now, just because of the ignorance, the desmetropism is also called as a tautomerism. Prototropy is also called as a tautomerism. Same thing is applicable, but small awareness will improve your score. Suppose there is a question, prototropy word is used, but until unless you know that the prototropy is as good as tautomerism, you are not going to attempt that and you are going to lose the marks. So tautomerism is also called as desmetropism or prototropy also. Okay. Okay, now we are further going to study about the tautomerism. Okay, it involves the migration of proton. That's why it is called as a prototropy. Why it is called as a prototropy? Because it involves the transfer, migration of proton. Migrate means moving from one place to another place. Within the molecule itself, molecule hydrogen will move from one carbon, one atom to another place. That is called as a migration of proton. Okay, so normally there are two types of migration, one to migration and 1,3 migration. Don't confuse this number with the IUPAC numbering used in the naming. This is nowhere related to that. Okay. So here let us take the 1,2 migration. The tautomers obtained in the 1,2 migration are called as a dyad system. Tautomers obtained in 1,3 migration is called as a triad system. Out of this, when you compare the importance, this is more important. Triad system is more important, and most of the question will be based upon the triad system only. But for safety purpose, I am introducing you, I am explaining about the dyad system also. Okay. So here cyanide, it is hydrocyanic acid. What it is? Hydrocyanic acid. Let us take this is on the first carbon. Don't think that why nitrogen is numbered. I am not naming. I am not using it for the naming purpose. Okay. So that's why I warned you. This numbering is nowhere with the IUPAC numbering. Okay. So this proton is on the first carbon, first atom. It will be migrated to the second atom. Then it is called as a dyad system. If this proton migrated to nitrogen, then this it will be formed. It is called as what? Isocyanic acid. What it is called as? Isocyanic acid. Cyanic acid, hydrocyanic acid, and isocyanic acid. They both will be in dynamic equilibrium with each other. Okay. Some molecules will be in this form, some molecules will be in this form. Both exist together, then only it is called as a tautomerism. It arises due to migration of proton from first atom to second atom. That's why it is called 1,2 migration. It is called as a dyad system. Okay. So migration of proton, I think I got clarity, you got clarity, and dyad system also you must have got clarity. Okay. So this is just important only for the information purpose. Okay. So mostly we may not expect some good questions from the dyad system, but most of the questions will be based upon the triad system only. In the triad system, what is there? It should be 1,3 migration. That means proton should move from first atom to third atom. Let it be anything, polyvalent atom. It should be what? Polyvalent atom. Okay. And in that, the most expected questions are from the keto-enol tautomerism. Okay. So this is one functional group. This is another functional group. Okay. 1,3 migration example is what? Keto-enol tautomerism. Okay. Okay, now let us see mechanism, how it works a keto-enol tautomerism, and why it is called keto-enol tautomerism. Okay, and why it is called triad system, why it is called 1,3 migration. Everything is explained here just with the simple, beautiful two diagrams. Okay, so this is a ketone, C double bond O. Actually, we cannot say that it is a ketone, but it was named earlier. That's why it is continuing, because if some hydrogen is there, okay, if some hydrogen is there, then it will become as a aldehyde. Okay. So for avoiding that purpose only, properly speaking, it should be carbonyl group. What it should be? It should be a carbonyl group. Okay. So this is a polyvalent atom. This is a polyvalent atom. This is a polyvalent atom. Okay. So presently the hydrogen is on the third with respect to the third atom with respect to the oxygen. Okay. 1,3 migration of proton from one polyvalent to another polyvalent. So this will migrate here, and but when it migrates over here, oxygen cannot make three bonds in the neutral state. In positive state, it can form three bonds. So, but that time what happens? This will be moving like this. Okay. So this is one. This is the first. This is second. This is third. Atoms I am telling you. Okay. So again, they both will be in dynamic equilibrium. It is not that always this will be in this form only. Okay. So this is how resulted, how it is understood. This single bond converted into double bond converted into single bond, and ketone, carbonyl group is converted to alcohol. Okay. So earlier, before the reaction, it was in keto form. What form it was? keto form. After the process, it is converted into double bond and alcohol. Double bond stands for ene and alcohol OH stands for ol. So they both will keep on. Sometimes they will switch like this. Okay. For few seconds, this will exist. After few seconds, this will exist. They are thermodynamic. Sorry, they are dynamically equilibrium with each other. After some time, what happens again? One three migration again it will takes place. Okay. This hydrogen will migrate here. This will go back here. So there will be switch will be always be available. But number of molecules in this form or in this form may not be same. That depends upon the stability. Suppose this form is stable, this percentage of molecule in this form will be more and in this form will be less. If this is more stable, keto form will be more number of molecule in keto form and this will be less. So this is the conversion of ketone into the double bond alcohol. That's why it is called as a keto and enol. Is it clear to all of you? All means alcohol, ene means double bond. On the same carbon, both are available. Okay. So triad system, how the keto-enol tautomers arise with each other. I think it is clear to you now. Okay. Okay, now we are going to study about the when this tautomerism exists. Okay, now we are going to study the conditions of existing of tautomerism. Okay, for a tautomerism to exist, most useful, mostly used example is this one. Okay, but it does not mean that it exists only in this one. And when the functional group like this N double bond O, okay, and when C double bond N, these are also shows, but there are rarely then less questions also there. Okay, so but you should be 100% prepared for this type of isomerism. Okay, so any of these three group must be present in the given compound. Second condition is there should be at least one alpha hydrogen. Okay, what should be available? There should be alpha hydrogen must be available. Without alpha hydrogen, even though these groups are present, they will not show the tautomerism. Okay, so examples like benzaldehyde. Okay, like benzaldehyde, I will tell you these groups are present, but still they will not show the tautomerism. Like benzaldehyde means like this structure everybody can draw. Okay, so this is the benzaldehyde structure. Okay, so with respect to this group, this is the alpha carbon, and alpha carbon does not have any hydrogen. That's why benzaldehyde does not show. Okay, benzaldehyde does not show what ketoenol tautomerism, even though this functional group is present, but it will not show due to absence of the alpha hydrogen. If you take the formaldehyde, formaldehyde even does not have alpha carbon only. Okay, HCH, there is no alpha carbon, so no chance of the alpha hydrogen, but this group is present. Okay, so both condition must be satisfied. What are the both conditions? Any of the three functional groups mentioned must be present. Second thing is alpha hydrogen is must. Where alpha hydrogen, I think now you will be able to identify. And one more example also I'm going to take trimethyl acetaldehyde. Okay, trimethyl acetaldehyde. That means like this. See, this is having functional group. Okay, but there is no alpha hydrogen. Okay, so once there is no alpha hydrogen, there is no chance of the tautomerism. For tautomerism to exist, any of the three functional group must be present and alpha hydrogen is also must. Then only they can exhibit the tautomerism. Is it understood? Okay, now let us see some examples. Now let us see some examples of Ketoenol tautomerisms. Few simple examples I am taking. So this is called as a vinyl alcohol. Vinyl means on the double bond carbon if something is attached. This is a common word used as a vinyl. Okay. So vinyl alcohol. On the double bond carbon OH is there. Okay. Now 1,3 migration should take place. 1,3 migration means this hydrogen should come from 1, 2, 3. Okay, this is not IUPAC numbering. Again and again I'm telling, from the first oxygen atom to third carbon atom, if it migrates, then this pi bond will move this side. Okay, so this double bond O is this one. Okay, so vinyl alcohol is converted to acetaldehyde. Okay, this is which form? Enol form. Enol form is called as vinyl alcohol, and keto form is called as acetaldehyde. Okay, next coming to the acetone. In acetone there will be three ketone form. Okay, so this will result in migration of hydrogen from here to here and double bond here. Okay, so like this will be converted to alcohol and double bond, isopropyl alcohol. This is isopropyl alcohol, which is enol form. Here enol form is this one, and this is keto form. Okay, so this is how you will convert keto form into enol form and enol form into keto form. Okay. Okay, now we are into the most important topic, how the enol content will be more in which one is having less enol content, how to identify. Okay, so first one, these are the factors. Okay, stability of enol. If enol form is having more stable, obviously its enol content will be more. Okay, so if it is aromatic in enol form, then it is going to stay in enol form only. If number of conjugations are more in enol form, then it is going to continue in the enol form. If hydrogen bonding is possible in enol form, then it is going to have enol form only. Then in keto form, acidic strength of hydrogen, alpha hydrogen is more, then factor this contributes to enol form. Okay, and whenever there is a presence of electron withdrawing groups, that will favor the enol content. Presence of electron withdrawing groups favors the enol content. Okay, these are all step by step. We are going to take one example, and I will explain on the each point. Okay. Okay, let us start with one by one example. This is a cyclic ketone and this is a cyclic enol, cyclic ketone. Okay, first factors affecting how to decide in which one enol content is more. Okay, so this enol content is more than this one. Why? Because it is easy for introducing. When it goes here, when it will come back here. Okay. So because of this, these two carbon will be sp2 hybridized. It is easy to insert pi bond in cyclic rather than in aliphatic. In aliphatic, it tries to stay in the sp3 hybridized form. In cyclic, it will try to stay in the sp2 hybridized form because of the bond angle 120, and sp2 also bond angle is how much? 120. Okay, so always try to introduce the pi bond in cyclic form. That's why enol content in the cyclic form is more than the similar acyclic form. First, how to decide enol content majority, first point, I think it is clear. Okay. Okay, if you understood that first point, now will you be able to apply here it or not? Okay, so like this question is, which of the following pairs will have more enol content? What is your answer? This one, because cyclic. Okay, cyclic compounds will contain more enol content rather than the aliphatic. First point, and it's based two questions. I think it is understood to everybody. Okay, if the question is like this, which will contain more enol form? Answer is this one. Okay, why? Because of the hydrogen bonding. Okay, what is the answer? Hydrogen bonding. So when there is a pi bond, transfer will take place. This is the alpha hydrogen. This alpha hydrogen will move like this. Okay, so its enol form will be like this. Enol form is going to be like this. C double bond, and this is going to be oxygen. This is going to be hydrogen. This hydrogen is this one. Okay. So there will be cyclic compound. Okay. So there will be a cyclic six membered ring. So because of this cyclic six membered ring, this is more stable. Okay, so due to the presence of hydrogen bonding in this, enol form is more stable. So more stable means more enol content. Is it understood? Hydrogen bonding question, how it will be there? Okay. Okay, if the question is like this is not a hydrogen bond question because both of them can form hydrogen bond. Okay, in the previous question, it was one was able to form hydrogen bonding, another was not able to form hydrogen bonding. But here this condition is similar. Only thing differ is here the hydrogens and here it is nothing is written means alpha methyl group. Okay, in this one acidic strength of the alpha hydrogen, this alpha hydrogen is more acidic than this alpha hydrogen. Okay, this is a CH2 group. Only this can give the alpha hydrogen, but this can also give alpha hydrogen. So the enol form will be more in this one, resulting in the intramolecular hydrogen bonding. Okay. Okay, if the question is like this, which logic you will apply? Here, oxygen is electron releasing group. What it is? Electron releasing group. Understood? So, what you have to see, electron withdrawing group, presence of electron withdrawing group or absence of electronic releasing group will be favorable for enol content. In this one, the presence of ether, it is just a ether only, COOR. Okay. So the ether content, ether presence will reduce the enol content. Will reduce the enol content due to the electron releasing nature of the oxygen with lone pair. Okay. Okay, if this is the question, where the enol content increasing order or decreasing order? So answer will be this one, number of conjugations. What is the reason? Number of conjugations. Suppose this is 100% enol content. Why? Because if this pi bond will come here and this hydrogen goes here, what it is going to form? The most stable benzene ring with the OH, phenol it is going to form. Okay, so it will never stay in the keto form, 100% in the enol form. Phenol is a enol form of this keto form. Okay, so it will never, because aromatic. There are more conjugations. Here less conjugations or no conjugations at all. Conjugations will favor the enol content, and here conjugation along with aromaticity. That's why here enol content is more stable. Is it understood? Okay, let's suppose this is the question. Arrange them in the decreasing order of enol content. Highest enol content is found in A. Okay. Second highest is found in B because one OR group is there. Okay. And third highest or lowest will be C. So here enol content is almost negligible and enol content is maximum here because of absence of electron releasing group. Here one electron releasing group here and here two electron releasing groups are there. More number of electron releasing group, less will be enol content. Less will be enol content. More will be the electron withdrawing group, more will be enol content. Okay. Okay, whether you understood my answer or not, my teaching or not, as a question I'm giving you. Okay, these are the three compounds. These are the three compounds. Will you arrange them in increasing order of, sorry, in increasing order or decreasing order of enol content? Send this answer to me. Okay, you can write it in the comment box. Answer A less than B less than C, or A greater than B greater than C, B greater than A greater than C. Okay. So if you are sending the correct answer means you are following my teaching and I am able to teach you properly, and you are able to write all the questions answer. Okay. So my request to everybody to make your own notes and study from the starting to the last with the same interest. If anywhere you find it difficult, you just pause it, take a break and come back to the same place and study with the same Josh. Okay. I think enol Tautomerism topic is completely understood everybody, and you will be able to answer all questions related to Tautomerism, especially Keto-enol Tautomerism. All entrance questions are covered in this theory. I think you will be feeling now easy for this topic. Okay, bye bye.